Okay, quotient rule. If we got a function divided by another function, sometimes these are known as rational functions, depending on what's in the denominator. Okay, so let's talk about the functions here. If you got one function divided by the other, the derivative is similar to the product rule in the fact that you take the f prime times g of x and f of x times g prime of x. One major difference is the fact that this is subtraction up top, and obviously the other huge difference is we divide by g of x squared at the bottom. Okay, here's a time when not to use the quotient rule. If you have a simple monomial divisor, you can just break this up into its components. Okay, maybe I had to rewrite this 1 over 2x to 1/2 x to the negative 1. Also, I do my power rule here. I do my power rule to the other couple things, and I get something that looks like this. Okay, typical usage would look something like this. X plus 1 over x minus 2. All right, so the derivative of x plus 1 is just 1 times the bottom minus the top function. The derivative of x minus 2 is just 1 over x minus 2 quantity squared. So if I wrote this out, this is x minus 2. Got to distribute your negative here, minus x minus 1, or negative 3 over x minus 2 quantity squared. We actually have this one in the book, and we know that this is an answer that we're going to have to basically memorize at some point in time. But just to kind of get in the habit of working with trig a little bit, if we have y equals tan x, that's the same thing as saying y equals sine x over cosine. That's just a rewrite. If I want to look at y prime, then y prime is the derivative of the top, which in this case is cosine x, times the bottom, also cosine x, minus the top function, sine x, times the derivative of the bottom. Derivative of cosine x is negative sine x. Okay? All this over the bottom one squared. Now notice that cosine quantity squared, you write it as cosine squared x. That's how it's written. You don't write it without parentheses because that'd mean cosine of some value of x squared, and that's not what we want. You write it either this way or this way. Do not just put the square out here without a parentheses involved. Okay, so what do we have left? We have cosine x squared plus sine x squared all over cosine x squared. Okay, this cosine squared x plus sine squared x here, I'll clean this up in class tomorrow, but basically it's an identity. It has to deal with the unit circle. You might know it already because you've been working with a little bit of trig identities before, but basically this is just 1 over cosine squared x, and I believe cosine is cosecant, so this is like cosecant squared x would be the answer here. Or is it secant? I think it's secant squared x. We'll go over again in class. Okay, one more quotient rule. Top, bottom, top's derivative times the bottom plus the top's original times the derivative of the bottom all over the bottom one squared. Again, don't forget to write it this way. Higher order derivatives. If you take the derivative of a function, we call it the single prime. If you take the derivative of the single prime, we call it a double prime. And I guess if we kept going, we could take the derivative of a double prime and call it a triple prime. Usually we only go to f double prime of x. Probably one of the more popular ways to take a look at that is the idea of acceleration. Okay. Other idea is what's called concavity, but we'll get to that later. But here in a position function, if I have a position function that gives feet away from a particular given starting point, then s prime of t, the derivative of this, would give us velocity, in feet per second, for example. And then the s double prime would give us the acceleration, which would be feet per second squared. So that's one idea of how you use higher order derivatives. Again, the other one is going to be the idea of the fact that a regular part is the tangent slope and the next part is going to be concavity. It's the difference between increasing, decreasing, and concavity. And again, we'll get to that a little later and reinforce that. All right, so you asked for some practice problems. So here's a couple of practice problems on quotient rule. All right. I'm going to attach these somewhere later, but if you don't want the spoiler alert right now, just pause the video right here, and I'm going to go through all the practice problems. I won't talk about them, but I'll just show you the answers.